Hello, everybody, and welcome to the introduction to week 3 of Math 1220 Online. Just a few announcements. As a reminder, your web work and your written assignments are due Fridays at 11:59 p.m. Every assignment week, you have both a web work and a written assignment. Web work seemed to go pretty smoothly for people. Just a reminder, you don't need to do anything extra to submit it on Friday. The problems you've completed and submitted on WebWork automatically get updated to your grade. It might take a few minutes or a few hours before it's updated on your grade, but all the problems you submit on WebWork will sort of be incorporated into your Canvas grade. And so that just gets locked in at Friday at 11:59 p.m., but there's no extra step to submit it. For your written assignment, you do have to sort of submit it on Gradescope by Friday at 11:59 p.m. I know quite a few people did not submit their written assignment. One assignment is or two assignments are dropped. Two written assignments and your two lowest written assignment grades and your two lowest web work grades are dropped. So if you missed this written assignment this last week, then you're not sunk. I mean, that will just be one of your dropped scores. But do try and get those in. If you sort of continue to miss your written assignments, your grade will be in trouble later on. Good. So that was just a reminder about the structure of how assignments work. Let me point out, so a lot of people have been asking me about working ahead, about working on a slightly different schedule to the class. So I'm going to post assignments 3 and 4. So those will be available by Monday at midnight. And so if you want to work ahead or you need to work on a slightly different schedule, hopefully that will give you some flexibility in how you do that. The reason that I'm just going to post those two is that goes up through exam 1. I don't want to post ahead of exam 1 because I want to make sure people don't get confused about sort of what they're supposed to be studying for exam 1 or sort of try to use things from further along when they're taking exam 1. So I don't want to sort of encourage people to work ahead beyond exam 1. But after exam 1, I will then sort of post the assignments 5 through 8, which are the ones that sort of go up to exam 2. So you can work on those with a little bit more flexibility if you want to work more earlier or work ahead and so on. Good. And then after exam 2, sort of the last ones we post up through the final and so on. Okay, good. So speaking of the first exam, that's from February 13th to February 17th. Just a reminder that you take it in a proctoring center. You have to schedule that, and you can do that in the schedule exam tabs. A few people have already scheduled exams. And you can already schedule the final exam actually, but and exam 2. Do make sure you get your exam scheduled before that week. There's still plenty of time, but so do schedule it at some point. There will be a practice exam available on Canvas the week before. So when you take the exam in the proctoring center, if you haven't done this already, so what happens is the exam is on Canvas. Some of the problems you submit on Canvas, some of the problems that just the problem is on Canvas, but you write it down on a sheet of paper, and that gets scanned and sent to me to grade. So if you want to, there will be a practice exam available on Canvas the week before that will let you sort of practice both the material and that structure. In terms of just the material, there are also a bunch of old exams or practice exams available at this website, which you can access via a Canvas link I just added on the front page. So if you log in and go to the course page, it looks like this. At the top, you have this link to the syllabus, office hours, web work tips, about the instructor, and now practice exams. So if you click there, that will take you to this page. That's a bunch of old exams available to practice with. Okay, so those are the main logistic announcements I wanted to make. I just want to say a little bit about the math for this week. So we're covering sections 6.5, 6.8, and 6.9. So you'll notice conspicuously, we are not covering sections 6.6 and 6.7. I'll say a little bit about that on the next slide, but let me first just tell you what's in these sections. So 6.5 is an application of the exponential function to studying growth and decay. So for example, like growth of population, compound interest, radioactive decay, things like this. Those are all sort of described, those can all be described using the exponential function. And so that's sort of what we're developing in this section 6.5. Then section 6.8 is about inverse trigonometric functions. So basically we're taking functions like sine, cosine, tangent, secant, cosecant, these guys, and we're trying to invert them. Now, when you do that, I just want to point out, you run into a problem right away, which is if you like look at the function like y is equal to sine of x. So here I've drawn sort of the graph of it. So here's minus pi, here's pi, here's 0. Well, if you look at that function, like it's not invertible. So if I draw a horizontal line, that's going to sort of intersect this at infinitely many points. So sort of somehow it fails the horizontal line test. And another way to think that is like, if I take any multiple of pi, then sine of any multiple of pi is 0. So there's sort of, it's not 1-to-1, it's not invertible. Good, so if you want to invert this, you have to restrict the domain. So that's sort of the first thing they start talking about this section 6.8 is restriction of domain. And basically, we just sort of, instead of trying to invert it everywhere, we sort of only try to invert it like right here. So we look, instead of, we just look between like minus pi over 2 and pi over 2. And sort of on that domain, like it is 1-to-1. So it's sort of even monotonic, so strictly increasing. So let me sort of just copy that over and I'll restrict the domain with my eraser. So I just sort of, oops. Try that again. So I'm just going to sort of erase everything outside of this interval between minus pi over 2 and pi over 2. So now I look on sine of x, restricted to interval from minus pi over 2 to pi over 2. And now this is a function I can invert. Sort of takes values between -1 and 1. So its inverse function will have domain, the interval from -1 to 1. And then the range of the inverse function will be sort of between minus pi over 2 and pi over 2. So good. So this is what's going on in this section. So if you're applying these ideas, we already studied about inverting functions, like when we were doing exponentials as the inverse of logarithm. But now for trigonometric functions, sort of we first have to restrict the domain in order to get a function we can invert. One thing to be careful about here is like there are lots of different choices you could make for the domain. Like somehow, like instead of going from minus pi over 2 to pi over 2, I could go like from pi over 2 to 3 pi over 2. And sort of on this interval, sine would also be 1-to-1. So we have some standard conventions we make, and you should sort of look in the textbook and sort of make sure you understand what are the conventions we make for like where we have restricted the domain, because otherwise sort of your answers like would be off by like a factor of pi. Okay, so just pay attention to sort of how that domain is being restricted when we do this. And then finally, in section 6.9, we're going to introduce the hyperbolic functions, like sinh, cosh, tanh, etc., and their inverses. And so these are just like trig functions, but basically, when you sort of start the theory of trigonometric functions, I mean, really, those are coming from looking at sort of points on the circle, x squared plus y squared is equal to 1. So if you sort of go back and look at your trigonometry, like cosine squared plus sine squared is equal to 1, and sort of like cosine is sort of the x coordinate of a point on the circle, and sort of sine is the y coordinate. So like if I look at the unit circle and sort of say, okay, so now I sort of have some theta here. I look at this point. This point is cosine of theta, sine theta. This is the unit circle described by this equation, x squared plus y squared is equal to 1. So somehow cosine and sine and sort of then all of the other trigonometric functions are built out of the unit circle. Well, hyperbolic functions are built out of sort of the unit hyperbola. So instead of x squared plus y squared is equal to 1, you have x squared minus y squared is equal to 1. It's like cosh squared minus sinh squared is equal to 1. And this is sort of illustrated in the textbook if you read this section. Okay, and so, well, these are useful, I mean, for plenty of reasons. They show up like in physics, for example, and engineering. For us, they sort of really show up because all these functions, like these inverse trigonometric functions and these hyperbolic functions, they let us, we'll be able to compute the derivatives. That's one of the things you'll do in these sections. You'll compute the derivatives of these functions. And so these derivatives end up being useful for integrating. So the payoff to sort of 6.8, 6.9 is really that knowing all these functions lets us compute a lot more integrals. So for example, you'll be able to compute like the integral of 1 over 1 plus x squared times dx. which is sort of something we wouldn't be able to compute. Like we wouldn't know the antiderivative of this until we have inverse trigonometric functions. And so you'll see other similar examples to this. Okay, so that's what's happening this week. Let me point out what we're not doing. So what happened in sort of 6.6 and 6.7? Well, these are two sections about the theory of differential equations. So a differential equation, that's an equation where the unknown is a function, and so the terms involve derivatives. So if you look down here, I've written down a simple differential equation. You're looking for a function y of x whose derivative is equal to the function itself. I'll come back to this remark in a second. So that's what a differential equation is. You probably sort of encounter these at least informally, maybe already in 1210 or an earlier calculus class, but sort of we do sort of explicitly skip this material in the calculus sequence typically. So what's in these sort of particular sections? Well, 6.6 is about using this exponential function to solve some sort of some specific types of non-separable differential equations. Depending on which calculus section you took, you may or may not have seen separable differential equations before. But this sort of 6.6 is really just sort of a technique for solving a certain type of differential equation. But again, this is not something we're doing in this class, so you don't need to know this. And then 6.7 is about sort of how you can approximate solutions to differential equations. This is very interesting, but again, sort of it's something we're not doing in this class. It's something you'd learn at Utah. You'd learn this later on in a differential equations course. So let me just reiterate one more time, differential equations are not in our syllabus for 1220, but I do want to point out one thing, which is that if you read section 6.5 in the textbook, they sort of emphasize, so this is about sort of these growth and decay properties of the exponential function. And so in their discussion of this, they really emphasize that y equals e to the x, that y equals e to the x is a solution to sort of the following separable differential equation, dy over dx is equal to y. So this is just sort of a statement that e to the x is its own derivative. You don't need to sort of really know what that means of what a separable equation is in general in order to understand this section. But if you're a little bit confused about what they're saying, or if you're just curious to know more about that, you can go ahead and turn back to the short section 3.9. It's pretty simple. If you read through that, you'll have a better idea of what they're saying here. Again, it's not required. You don't need to understand this point in order to do all the things we're going to do with the stuff from section 6.5. I just pointed out in case you're curious. Okay, well, have a good week.